Hello, everyone. Welcome to ChiPy, or the Chicago Python User Group. I am Joe Jasinski. I'm the host for tonight. And before we get started, I would like to talk about our code of conduct briefly. Please check out our code of conduct at our website on chipy.org. And basically, and please abide by the code of conduct as you interact in real space and in virtual space. But what is ChiPy? ChiPy is the Chicago Python User Group, or one of the largest Python user groups in the world. We've been around since 2003 and have been having regular meetings since then. We started off in the back of a small bar and have grown to be a membership of a few thousand people on our various online communities. So welcome to our stream. The ChiPy kit wouldn't be possible without the help of all of our dedicated volunteers, some of which are our board members. The board members are the people that lose sleep at night trying to make ChiPy happen, but we have so many other organizers that do our special interest groups and volunteer in many different ways that we couldn't do everything we do without their help. So a big thank you to them. ChiPy has a bunch of initiatives that we do, one of which is the Python Project Night, which is an opportunity for people programming in Python can come together and work on various projects, and it's a great space for you to meet people who are similarly interested in Python. We have the Buddy Mentorship Program, which is kind of an extension of our earlier mentorship program, where we pair mentors and mentees together to learn Python and work on a similar project. And we have the Python lunch break, which is meetups during the lunch break. So I mentioned the ChiPy Mentorship Program a little bit before, but you can find out more information about that by going to chipymentor.org. We also have a relatively new job post board. So if you're looking for a job or looking to post a job, please check that out on our chipy.org website. Finally, we have a number of special interest groups, which allow us to dive a little bit deeper into various topics of Python. We have the Finance Special Interest Group, the Data, the Web Dev, and Algorithms Special Interest Group. So if you're interested in learning more about a various topic in Python, check those out. We have a number of upcoming ChiPy events, one of which is the Virtual Project Night coming up on January 21st. We're relaunching the Project Night in our online space called chippy.town, which is like a little 2D interface. You can have little video chats with other people as you kind of walk closer to them. We have a meeting of the ChiPy Algorithm SIG on February 4th, and a February 11th main meetup, and another project night coming up. So a few things on the board. You can find out more information on our meetup.com page, which I'll link to in a minute. So this takes us to tonight's schedule. We have 3 great talks, and I'm really excited to get started with those. We have the First Time Advent of Coding by Stephen Iano, The Making of Scaled Data Science Workflow for People and Not the Other Way Around by Hugo Brown Anderson, and From Python to Rust by Kevin Nasto. During the meeting, feel free to engage in the YouTube live chat on the side here. So if you have questions for the speaker, feel free to ask them for when we do the Q&A with them. Or if you have Python-related topics you want to chat about, feel free to make a post. And to get us started, to get the chat started, if people are interested, please mention what your favorite Python library is in the chat. After the meetup, we're going to have a hangout in chippy.town, which, as I mentioned before, is our virtual meetup space. So if you want to engage with the speakers or each other, or just hang out, or whoever wants to show up, join us here at chippy.town. I'll send a link after the meeting. Also, if you want to find us outside of, we have a number of different ways you can find us, one of which is our Slack channel, which we have a number of different channels on a lot of different Python topics. So feel free to join us on Slack and get started with talking Python with us. We have a Twitter account at ChicagoPython to find the latest news and updates. And finally, if you don't remember anything that I just said, if you go to chippy.org, that can act as a jumping off point for all of these other resources. So check that out. The website has a lot of good information, and it's continually being updated with new features and such. So please take a look. I would like to introduce Ari Weller, our sponsor from Jfrog, to talk a little bit about his sponsorship.
Hey, thanks, Doug. I really appreciate it.
Hi.
Happy 2021, everyone. Did you ever think we'd get here? Well, we're finally here. I'm Ari Weller. I'm the Meetup event manager for Jfrog, and we're really proud to be part of the ChiPy community in 2021. I'll share just a little bit about who we are at Jfrog. Jfrog is considered by many to be the DevOps software company. We were founded in 2008. We are known by many for our flagship product, Artifactory, which is the world's leading universal binary repository. In fact, the open source version of Artifactory was released in 2006 with the purpose of making the lives of developers easier. Today at Jfrog, we have nearly 700 employees, 10 offices globally, and more than 3 million software developers use our software tools daily, many of them Python developers. So for tonight, Jfrog is going to give you a chance to enter and win an Adafruit clue so that you can play with some Circuit Python on your own. We're going to actually be planning to raffle one of these off at a lot of the meetings this year. Also, along with that, if you don't win that, we still have one of 3 limited edition Jfrog t-shirts, one of which I'm wearing, that we'll also be giving away too. So you can enter with the QR code or bit.ly link that you see. And also, we're going to drop it into the chat that you see on YouTube for you to enter as well. Just some side note, also especially for the community, Jfrog has created a free cloud-based subscription tier of service to our DevOps software. So there's no credit card required, and these free tools include Artifactory with built-in vulnerability scanning capabilities. So if you're working on some side projects or you just want to try out some DevOps, if you're not doing it full-time, I'll drop that link in there as well. And again, thank you for having us back in your community in 2021. Really appreciate it. Back to you, Joe.
Thank you very much for your sponsorship. We couldn't host ChiPy events without help of sponsorships such as yourself. So
thank you. You guys are really, really great, and it's an awesome community, and so proud to be part of it.
Thank you. All right, I'm going to bring on our first speaker, and we can get started with the talks. Hi, Stephen. Welcome to ChiPy.
Hi, thanks for having me.
Thanks for coming and talking with us. Before we get started with your talks, I would just like to learn a little bit about yourself. Tell me kind of a little bit about yourself and how you found your way into Python.
Yeah, so I'm actually really new to Python and really new to ChiPy as well. I've been working as an educator like the past 7 years, and about a year ago, I decided that it was time for a career change. And that's when I really started discovering programming, because I was just looking for other careers in the world. And so I know coding was a big one, but I had never really coded before. And so I just started teaching myself, and I found that I really thoroughly enjoyed it a lot. And so I just started investing so much time into getting better at coding. Took a data science bootcamp over the summer and joined ChiPy in October. And Advent of Code, obviously, this is my first time doing it because this is my first year really programming. But Advent of Code was a really great experience for me and a great chance to just learn.
So during your experience with Advent of Code and just learning programming in general, did you use any other languages, or is Python your primary language? Or...
No, for this one, I exclusively use Python. Python's definitely my predominant language. I do a little bit with JavaScript, but that's about it. Mostly those two.
Cool. So, this has obviously been kind of a rough year for a lot of people with COVID and such. How have you been dealing with the situation and occupying your time?
I mean, it's definitely a tough time for everybody. It's really tough to do a career change during all of this. So that's really been a challenge. I mean, I've been able to focus a lot of my time on just learning Python, and that's been awesome. So I have a lot of time to do that. So I've definitely developed a completely new skill, and I feel like I've really gotten a great handle on it. I was able to complete all the challenges in Advent of Code. So, and I'm continuing to learn so much more. So I'm just mostly spending my time learning a ton of programming and web development and the full stack, and even front end. I've been dabbling with front end recently.
Yeah, there's certainly a lot to learn, and a lot of fun stuff, and
Never ends.
Yeah. Well, thank you again for joining us, and let me. Do you have a screen you want to share, or we can get you started?
Yeah. So I did want to mention, in doing Advent of Code, I mentioned I'm really new to ChiPy. I just joined in like October, and because everything's remote, it's so difficult to actually interact with people or meet people. And with everything being on video, and you can't mingle, makes it really difficult. Advent of Code was really awesome because every single night there were a group of us who were constantly solving the same problem. And most of us were putting all our solutions on our GitHubs, and then we would share our solutions and look at each other's codes and learn from each other, talk about different approaches and the solutions. And so for me, that was just an awesome way to engage with the community and meet new people who do this thing that I really like doing. And as I mentioned, like, we looked at each other's code a lot, and so that was a really great way to learn. So I mostly just wanted to share this tiny little trick that I learned that I thought was really, really cool, and I managed to implement it on a later challenge in Advent of Code. There were a ton of like grid related questions, and particularly a whole lot of like game of life style iterations this year. And one of the really cool tricks that I learned with grids, just from looking at other people's code, was using imaginary numbers. And I'll show you how this works. So right now I'm sharing my screen. This was the 24th challenge of the 25 days. And it's basically a variant of Game of Life, as I was mentioning, but it's with a hex grid. And so instead of your typical square grid, and I'll show you what that looks like. So you have these hexagons here. And the way that this challenge works is it lists off these directions, like southeast, southeast, northwest, northeast. And you have to identify the location of a hexagon and say whether it's black or white. And in this example, there might be a hexagon that is listed twice, but you wouldn't know it by looking at these lines of code, because you have to figure out the actual location of it. And from there, you figure out what color it is. So here is an example of what this looks like in terms of finding the location of a hexagon. You can do tuples, but basically the idea is you go to the right, that would be adding 2 in the x coordinate, and then you go down, that's adding 1 in the y coordinate, 1 in the x coordinate. But that would be using tuples, and that's what I would have done previously, but I found this really cool hack with imaginary numbers that I really, really like. So here's my solution posted on my GitHub.
One quick comment. We have some people in the chat asking if you could make your screen a little bit bigger.
Oh yeah, sure thing.
Thanks.
Is that better?
Maybe a little bit more.
Oh yeah, zoom in a bit.
Oh yeah, that works.
Is that clearer?
Yeah, thank you.
All right, so basically the challenge gives you a hexagon right in the center, and it gives you all these different directions as I showed here. So these are just directions. So southeast, southeast, northwest, northeast, 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 west. Yeah, so on and so forth. And you just kind of got to parse it to get all the directions. But I made this direction dictionary, which takes advantage of imaginary numbers. And what the imaginary numbers do is they do the whole y-axis. And it just makes it so much simpler than adding tuples, adding like the 0 index and the 1 index of the tuples. Your imaginary numbers basically create their own 1 index instead of actually having a tuple. So using this direction dictionary, I was able to very easily locate every coordinate for the hexagon and identify any duplicate hexagons within the input. So this is the actual input. It's just very, very long. So there's like a bajillion different tiles. And you need to, for the first challenge, you need to identify how many. So it says if a tile is mentioned for the first time, then you flip it to black. If it's mentioned a second time, then it's flipped back to white. And so you have to mention how many tiles are black after you've gone through the entire input. So that was the part 1. And then part 2 is pretty similar. It's just looking at neighbors. And then if it's a variant of Game of Life. But the whole idea is just this really, really cool hack with using imaginary numbers. If you're ever working with grids, this just makes everything so much simpler. So I just wanted to share that with you. That was a bit of a mind blow when I first saw that. So something easy to remember and easy to share. Yeah, that's what I want to share with you.
So for new people who are interested in Advent of Code, like what would you recommend? How would they get involved? How you know, what level of skill do they need with, and what advice do you have generally?
Oh my, good question. I mean, for me, Advent of Code is really where I feel like I connected for the first time. I had been to some of the algo sigs and the project nights, and I guess what's hard about it with the whole remote factor is it's hard to interact with people and it's hard to talk to people. But doing the Advent of Code, it was much easier because we're all chatting away. So that was really exciting. So in connecting, I would just say be engaged and reach out to people. Since Advent of Code, I've reached out to some of the other folks who did it, and then I've been able to connect with them and build more of a community, which is great during this time period and in general.
So we have a question from Ray Berg. What was the worst Advent of Code problem?
Worst Advent of Code. So the worst, do you mean the hardest, or like the one that I'm just like, I don't like this? Give me a moment. Sorry about this.
No worries.
Okay. The worst one, at least the hardest one, I'll go with the hardest one, was this question dealing with these tiles. You're sent like a bunch of different tiles, like 144 tiles to be exact, and they're all rotated and flipped. Like they're not oriented the way that they should be, but like the margins of the tiles are the key for how you line them up. But you got to flip them or rotate them to figure out how they're supposed to line up. And then once you actually get them lined up, which is, it was very, very difficult to get them lined up. That took me forever. And from there, you got to get rid of the keys and you got to compress the boards to make like a big image. And then it gave you the pattern for sea monsters. And you had to determine how many sea monsters were present in the image. Should I show this? It's very visual, so
sure,
maybe that would be helpful. But this one took me the longest amount of time. I had to go like several hours, and it was very, very challenging. I think it's this one. It was, yeah, this one right here.
Let's see.
Okay.
Yeah.
Let me share this. This was the code here. So you have all these tiles that are just dots or hashtags. And again, they have to match up. So they give an example of this. So there's all those tiles. And then you see like on the axes, they match up. And that's how you know that they're supposed to go together. So the first part was fairly simple. It's like which tiles are the corners, and that was doable. But what was hard was the second part, which was then you have to put them all together, get rid of the margins, and then remove the gaps as they show here. Let me zoom in, that would probably be better, even though it's really hard to see anyways. Okay, and then you have your full image, and then they give you this pattern which represents a sea monster. And so they made it kind of nice in that there's only, because like the way that it's lined up right now, you're not going to find any sea monster patterns. You got to orient it in the way that you'll actually find sea monsters. So you got to flip it and rotate it. So there's, from that perspective, there's 8 different ways to look at it. And once you rotate it the right way, you'll find some sea monsters. So in this case, there are 2 sea monsters in the example that they give. And once you find the sea monsters, you exclude those hashtags from the image, and you have to return how many hashtags are in the image. And so that's what you had to return. This one took me a very, very long time. I don't know if it's worth looking at the code. Is that too much?
If you want to show it, sure.
I'll show it quickly. The hardest part was just putting the board together. Let me see, what can I even show? Yeah, so I created like a match dictionary, which I created a lot of dictionaries in this one actually. But the match dictionary, the whole idea, it's a default dict with a dictionary as the value. And so for each tile, I'm putting in the grid itself of that tile. Where is it actually? Oh yeah, it'd be easier to actually output some of this. But I find the side that matches the other tile, and then I put, like if it's the right side of that tile matches the left side of another tile, that's what would go into the dictionary. And then from there, I had to make this recursive function.
Can you make it a little bigger?
Yeah. This is too much. There's a lot going on here, and I don't know if I did the best. So then I had this recursive function to make a row. So I start with the top left tile, then I get the match, and I have to rotate it so that it's oriented to be upright, and then I have to call the next one, and that's where the recursion comes in. And then the return is just like a horizontal stack with NumPy with a recursion inside. So it basically goes from one end, like the top left, to the top right with everything in between. And then I have another function here which makes use of this function to make a row, but then you're doing a vertical stack to recursively build out the full grid. So yeah, there was a lot that happened with this one. This one was pretty tricky. Took me a long time. And then this is just looking for the sea monsters, which was probably the easiest part of it all, once you make the grid. Yeah.
Cool. Yeah, do you have anything else you want to talk about Advent of Code, or
just that, like, I had a great time with it. I learned so much. I shared that small trick with y'all, but it was just definitely a great chance to practice and get better at writing code and thinking about things analytically. Right now I'm doing interviews, and so just having the practice with Advent of Code really helps prepare for those like take-home challenges that employers give.
I would imagine, yeah, I imagine that'd be really good interview practice for sure.
Yeah, definitely. So hopefully something will come together for me sooner than later.
Great. Do you have any, before we close up, do you have any calls to action for the Python community or any announcements you want to make?
Calls to action, just be engaged and don't be afraid to be challenged and don't be afraid to ask people for help. I think that's the best way we can interact with each other is ask and offer up help. And definitely just stay active coding.
Great. Well, thank you for joining us, and thank you for sharing your insights on your experience.
My pleasure. Thanks for having me.
Yeah, thanks for coming. All right, we're going to bring our next speaker on the call. I'm going to bring up Hugo. Let me add him to the stream. Hi, Hugo. Welcome.
Hey, Joe, and hey, everyone. Thanks for having me.
Thanks for speaking to us.
And thanks for all the hard work that you all put into this as well.
Thank you for your talk. Before we get started, tell us a little bit about yourself. What brings you into Python? How'd you get into it?
I used to work in academic research in basic science, in cell biology, biophysics, cell division, thinking about cytoskeletal dynamics, essentially. So like mitotic spindles and the railway tracks for cells and that type of stuff. I was ostensibly hired to do mathematical modeling of biological phenomena. Became apparent that I was working with biologists who were dealing with pretty large data sets. This was in 2011. And I was like, I really got to learn how to, I'd done a bunch of stats and applied math, needed to jump in and figure out some tooling to analyze these large data sets. And lo and behold, a very nascent PyData ecosystem. I jumped into what was then IPython notebooks, started using them in 2011. And then the scene exploded.
Yeah, that's for sure. Like Python seems like the go-to language for data science nowadays.
Yeah, Python and R. I think for analytics, R is perhaps definitely, there's a lower barrier to entry. That may be controversial. I'd be happy to discuss that at another time. But in fact, I think the fact that RStudio abstracts over the terminal actually makes it a lot more approachable for non-programmers. So a lot of people working in research science, biologists, social scientists, all of this type of stuff. And the statistical frameworks there are more approachable.
So besides Python, what's your favorite language?
And Python is my favorite. Okay. It's not, who said, maybe it was Tom Caswell, who said it's the second best tool for every task.
Yeah.
Which I think speaks, like I've referred to it and people refer to it as a Swiss Army knife, right? So it's not going to be the best thing for any given task, but it can do anything. And it's a glue, right, that you can use to structure and put everything together. Besides Python, to actually answer your question, and this may have been foreshadowed by my comments about the tidyverse in particular. I've worked in data science education for half a decade, and the aha moments, seeing people trying to answer questions, be able to use dplyr and ggplot2 and the tidyverse in order to answer questions in 3 or 4 lines of code. I mean, I'm a huge pandas fan for a lot of reasons. There is an argument that the tidyverse and dplyr in particular and ggplot2 kind of mimic our mental models of how we construct group bys and plots and layers. The grammar of graphics is applied to data manipulation as well. So the low barrier to entry there, I've just seen so many more people trying to do basic analytics go, aha, when you introduce them to R, as opposed to, the Python and the version control and the notebook. Like you teach version control, right? You tell people it's important and then you show them Jupyter notebooks and it's like, what on day one, end ramp.
So this has been kind of a tough year, and what have you been doing to kind of keep active and keep well with in light of COVID?
Yeah, so I've had everyone's had their own story the past year. A friend of mine tweeted out recently, 2020 didn't start till March, so we shouldn't expect it to end until March, which I feel is definitely helpful in light of recent events as well. my story has been, I've lived in the US for 7 years. End of March, I lived in New York, in Manhattan for 6 years, and end of March, you may be able to tell from my accent that I'm not a native North American. I joke that I'm from the South, but really far south. I'm from Australia, and at the end of March, I came back to Australia to be closer to my family. So the one thing that's been keeping me going is just having closer access to my very old friends and my family, and that's been really nice. Going for afternoon walks with my dad, who's 81, has like been incredible. So yeah, cool.
It's good to rely on family for getting through this time. Well, thank you again for joining us. And if you have I'll start sharing your slides, and why don't you take it away?
Fantastic. So I'm talking about kind of the culture and community of doing scaled data science work and making scaled data science work for us and communities, not the other way around. I currently, I'll give a bit of insight into what I've been up to. So to place a bit more context, so my background, as I hinted at, is in math and biology and physics. I did that in Germany. There's a Max Planck Institute for Cell Biology and Genetics in Dresden. Then I moved to New Haven and spent 2 years at Yale University, Connecticut. Didn't quite agree with me, or I didn't agree with it, so moved to New York City. Then I went to the dark side and went to industry, doing data science, education, evangelism at a company called Data Camp, where I built out the base Python curriculum and did a few other things. And at that point, I really became I fell in love with the open source community in a lot of respects, through collaborations on curriculum with what was then Continuum Analytics and is now Anaconda. And actually, it was at that time that I met my now CEO and the founder of Coiled, Matt Rocklin, who created a package called Dask around 2015, 2016, which essentially is for scalable data analytics native to the PyData stack. And we'll get to this, but the basic premise is that one of the goals, there were technical goals of Dask, but one was to invent nothing. And that was a social goal. And what Matt really means by that is that they wanted to meet PyData users where they are. So the Dask data frame API really mimics the Pandas API. Not so you don't really have to write so much new code. Not only that, but it actually executes Pandas code in the backend. So your mental model of the code you're writing actually matches the mental model of what's happening. So you don't end up being spewed like JVM errors when you're trying to import a CSV. So I'm working on evangelism, marketing, doing bits and pieces of product. You can find me Hugo Bound at most places. Abdi has a great question. Do you have to be good in math to be a good programmer? Most programmers say they know a lot of math. I think the best thing math provides is a structured way of thinking, and you can get that in other places. But I do think math definitely helps by providing that type of structured way of thinking and algorithmic ways of thinking. But I definitely don't think you need to know a lot about multivariate calculus. Having said that, if you want to do deep learning engineering, multivariate calculus may be helpful. But I definitely think mathematical thinking helps, but you definitely don't need to be a PhD in math. If you want to get in touch, reach out to hba@coiled.io. And if you want these slides, just go to bit.ly slides and put your email in and I'll send them to you, or scan this QR code as well. Okay. So in terms of talking, also, I just want to say once again, thanks for having me. I'm actually a huge fan of Chicago. I've never lived there, but having lived in the US for 7 years, I've been there many times. The last time I went there was actually 6 months prior to COVID, and I had the great fortune of doing a David Beasley course, stayed up in Andersonville for a week and sat down with David Beasley and a handful of other people, writing and learning Python code every day, which was a real joy. So rock on, Chicago. Great. So when talking about scalable data science, I first want to answer some questions around big data and think about whether it delivered. Then I want to dive into kind of the fruits of big compute and big data, and kind of structure some misconceptions about scalable data science that it's around big data, whereas it's really around big data, big models, complexity science, these types of things. So you can require scalable compute for large hyperparameter sweeps in a machine learning pipeline, even on a small data set. Then I'm going to talk about scalable data science and machine learning, and then talking about more cultural stuff, like how to build a healthy distributed data culture, okay? And this is something like the advent of data science has kind of taken us all by storm in a lot of ways. So thinking about how to actually build out a healthy culture there, okay? So did big data deliver? So what I'm going to talk about is, firstly, is it all hype? Then talk about how we got here, and then mention a couple of alternatives. So the power of small data and the power of thick data, which we'll figure out what that means in a minute. One framework for thinking about technological innovation is the Gartner hype cycle, particularly when we're thinking about hype and buzziness. So it really, what it thinks about is how we consider expectations of a particular innovation as a function of time, okay? So we have a trigger, then we get a lot of expectations, and then we realize that, and recall, this is just a model of technological innovation. There may be several peaks, for example, different peaks across different verticals, different parts of society, different demographics. But we get a peak, then people are like, wait a second, is this really all we think it is? And we go into a trough of disillusionment. Then after that, we get a slope of enlightenment where we actually see, value delivered into a plateau of productivity. Okay, so I usually do a poll question around this. In the interest of time, I'm not going to do that today. But I'd encourage you all to ask where you think big data is in the Gartner hype cycle. I'm not going to answer that, but I'll give one way of thinking about it, okay? So we can look at Google Trends, which we can consider a proxy for societal expectations, right? So what we see is that we started to see something happening, 2010, 2011, and then we saw a peak around 2013, 2014, and slowly going down. So it seems like we're really entering the trough of disillusionment here, okay? And as I said, we'll get to this. My personal, slightly informed opinion is that, this does differ across verticals. I think big data has delivered a lot in tech, for example, but in other verticals, it's definitively still yet to, okay? So how do we actually get here? So I want to talk about post Google search engine, for example, an article Chris Anderson wrote for Wired called "The End of Theory: The Data Deluge. The amount of data makes the scientific method obsolete." And Anderson's provocative hypothesis there is that we don't need to know about mechanism anymore. We don't need to have mechanistic models because we have essentially machine learning on big data and enough data in order to tell us how to automate decisions. In this case, among other things, show people what ads to show. Depressingly, show people, decide which ads to show to get people to click on them. Depressingly and cynically enough. But the basic idea is here that you have enough data and you don't need any theory then. And of course, we've seen where you end up with that type of model. And of course, there are historical precedents for these types of things. So evidence-based medicine, I think, you don't necessarily need all types of mechanisms in order to prescribe certain things. But I do think, of course, we've seen that the data deluge definitively does not make the scientific method obsolete. Okay, so I want to talk about how we got here. Why are we even talking about big data? Why is it useful? And there are really three things. This is a really interesting interactive visual from McKinsey of all possible places, called something like a business guide to AI or something relatively generic like that. But it's actually quite informative. And we can see these are the three things that kind of led to where we are. We had algorithmic advancements. We have the explosion of data, and we have the exponential increase in computing power and storage. And we can see, even getting, a few years ago, the number of mobile devices exceeded the number of humans. electronic device users generate 2.5 quintillion bytes of data per day. I mean, what even is a quintillion? It's definitely super large. And then we have AlphaZero beating AlphaGo Zero after learning to play 3 different games in less than 24 hours. These are all phenomenal things. I will make a small aside on the AlphaZero and the way such, you know, deep reinforcement learning based approaches to game playing yields extremely impressive results. I will just make clear, although it is incredibly impressive, playing games is just one thing. A lot of the decisions that we want AIs or machine learning or these types of things to do in the real world definitively aren't rule based in this sense. So I would encourage caution on many fronts in over-interpreting these types of things. All that having been said, I'd like to talk about the power of small data, which is, I think we've lost sight of in some ways. So on the left here, so on the right, I'm sorry, we have Tycho Brahe, who was a Danish astronomer, who actually, I'm sorry, I just need to fact check one thing. If you bear with me. Yes, okay. I just wanted to check the precise nature of Kepler and Brahe's relationship. Brahe was an astronomer who generated a lot of data, but small precise amounts of it, that Kepler then based his laws of planetary motion on, okay? And the size of the data set was on the order of 2,000 data points, which Kepler, who was his assistant, based his laws of planetary motion on after Brahe's death. Side note, Brahe was very protective of his own data, and actually Kepler had to wrestle with Brahe's family in order to get it after the fact. So there are all types of questions around data ownership here as well. The point is that Kepler was able to develop 3 laws of planetary motion, which Newton then based.
It looks like we had some technical difficulty. Hold on one second while we get the next speaker back.
Hey,
welcome back. Let's see. Thank you for.
Sorry about that.
No worries.
Is it going all right in general?
Yeah, it's going great. I'm going to add your slide back, so I think you're good to go.
Great. All right, everyone. We're back in action. My browser crashed, so appreciate your patience and flexibility here. The point is that we have rich scientific theories based on small amounts of data, and that's something we've lost sight of in this big data revolution. Insert big data pun here. And Raymond, I'm so glad you're loving the talk. And if you like the small data stuff, I'm really excited to tell you in a second about thick or qualitative data. The other example of small data that I want to make clear is polling. Of course, this slide predated recent events. I almost deleted this one. But the truth of the matter is that polls of small numbers of people, where you do it in a very principled manner and understand the correction methods you need, can yield very strong results. And so, as Andrew Gelman writes here in Scientific American, a poll of only 1,000 Americans can represent 260 million people with only a 3% margin of error. Now, we've seen the limitations of this type of thing recently. I don't think that comes down to sample size. It actually comes down to, of course, methods and lack of correction methods. The point being that if you have very precise principled methods of data collection and where you understand the data generating process, that's far better than having kind of vague, loose data and lots of it. Similarly, we've seen the advent of articles in HBR of small data product. Small data is enough to create smart products. And as it's stated here, it's not about mountains of data. It's about small, high precision data. Okay. Now I want to tell you a bit about thick data, which is qualitative data. And this is a sociological, anthropological term that there's a wonderful consulting group called Red Associates. Just a sec. And I'd encourage you to read up on some of their work. And they've been written up in Wall Street Journal and HBR. And they come in and help businesses that use, for example, machine learning models, think about how to get qualitative data to improve the performance of their models, to increase lift of their models. So one example that I think is really telling is, I think one key use case of machine learning is credit card fraud. So you have rows which are transactional data, time of transaction, how much, location, these types of things. And you want to predict whether these lines are fraudulent or not. You train it on a bunch of stuff where it was fraudulent or not. Use that to predict on new transactions, okay? So credit card company calls up Red Associates and says, we need lift on our model and we don't know how to do this. Should we collect more data? And Red Associates said, no, let's think about actually getting thick data or qualitative data, right? So to this end, what Red Associates did was they actually met a bunch of credit card fraudsters on the dark web. And the fraudsters, they said to the fraudsters, we're trying to build better models to detect your activity. Would you be up for chatting with us about your practice? And a bunch of fraudsters were like, yeah, bring it on. So they actually conversed with these fraudsters and figured out that a lot of the technological stuff the fraudsters have, people committing fraud, they've got, their firewalls and VPNs and all of this type of stuff. So it's very difficult to track them online. But of course, when the transaction often ends up in a delivery of some sort of goods or consumables or whatever it is, and this is a point of failure in this process. And what I mean by that is someone committing credit card fraud, when they get a delivery, Red Associates discovered, will not have it said to their own address, of course. They won't have it said to a friend or family's address. They'll be cleverer than that, of course. They'll generally have it sent to an abandoned house or a house on the real estate market and then pick it up. So what Red Associates suggested to this credit card company was to take their line items, their rows of credit card transactions, and look at the delivery address and join that up with tables that you can find public records of these addresses, whether they're on the real estate market or whether they're abandoned, and use that feature as a feature of the machine learning model. What status the house actually is. Is it occupied, abandoned, or on the real estate market? And lo and behold, they saw a significant lift in their model that increasing the training data by tenfold wouldn't actually produce. Adding a column containing this type of thick or qualitative data based on sociological research, essentially going on the ground and figuring out the data generating process there. So Cullen has a great comment, not exactly a question, but I saw a company saying that they leverage massive data in their press release. This is why you can't trust marketing departments. I totally agree. And I'm even more skeptical of marketing working in marketing myself now. But we'll get to that. Okay. Oh, I did not intend to unpresent. So this is really just giving some examples of why we need to be skeptical of big data. So to recap what we just went through, we talked about, is big data all hype? We talked about how we got here. We talked about the power of small data and the power of thick data. So having said all that, where has big compute and big data actually delivered value. And most of the examples I'm going to go through are in PyData ecosystem, because we're here and because I work in the PyData ecosystem, pardon me. So first, I want to talk about the wins of big data, then talk about the successes of big compute across a variety of verticals, and then a brief interlude to Dask. I'm not sure whether this is the forum for it, but it'd be nice to know who's heard of Dask. I don't know if we can have questions, but maybe if you have or you haven't, you can comment in the chat as well. So I think undeniably we've seen successes, and by successes, be clear, the first metric of success I'm talking about is in terms of generating revenue. Okay, I'm not necessarily talking about social or societal successes. And thank you for the 100% respect for the beard. I appreciate it very much. It is summer here, so it's getting pretty hot up in here, but I'm committed to the cause. Fantastic. So we've definitively, for these companies, for Google, Netflix, Booking.com, Stitch Fix, seen absolute successes in the application of big data to their business models. Okay. But we've also seen it across a variety of other metrics. Verticals. So in Walmart, in supply chain and retail logistics, I think is a fascinating example. I also love this example because I actually think Walmart and supply chain analytics, going back nearly half a century actually, are some of the first really big ancestors of modern data science as we know it today. So John Bowman, the director of data science labs at Walmart, has said, we're attempting to develop forecasts for 500 million store item combinations every week with a 52-week horizon. Huge forecasting problem, okay? So the acceleration they've seen with XGBoost, Rapids, and Dask, and Rapids comes out of NVIDIA. So yeah, the acceleration they've seen with random forest and gradient boosting is on the order of 100 to 1. And you can check out, sorry, this keeps flipping around, the NVIDIA blog for some Walmart information there. Okay. Grubhub is a really interesting example of query embeddings, trying to figure out what customers actually want. And they use Dask and distributed compute at a lot of different places along their pipeline there. And in fact, we had Alex Egg, data scientist at Grubhub, out of Brooklyn, come and talk with us we do these live streams at Coiled, Science Thursdays, where we talk about big compute applications and Dask type stuff. So feel free to come and check those out if you're interested. Great. In the life sciences, we've seen a lot in high resolution cellular imaging. Okay. Tally Lambert from Harvard Medical School has said that Dask lets him prototype pipelines on his laptop and scale them easily to the HPC that they have at HMS. And as we'll get to, the fact that it mimics common APIs made adopting it nearly effortless. And one way I like to think about Tally's work and a lot of research scientists is it allows them to stay in a flow state with their work. And what I mean by that is previously, they would get all of these high resolution images in, they perform some form of de-skewing or whatever it may be. This could even, all of this collection and analysis can take overnight or over 2 nights, whereas doing it on the fly with Dask in the back end allows them to do it almost in real time. Similarly, there are people who use Dask for large-scale simulations and of lava flows or atmospheric stuff, right? And it allows them to visualize these simulations in real time with IPy widgets right in their Jupyter notebooks or Jupyter Lab, which is super exciting. In finance, at Barclays, for example, this is not only a big data problem, but it's a big compute and complexity science problem. Okay, so this is a visualization of the types of questions they need to answer, where each dot is a small Python model and each line a relationship between models. Okay, so as it says here, financial modeling combines hundreds of individual models with complex dependencies, and Dask allows data scientists to handle all of these complex dependencies. And Barclays has said, we love that Dask lets us write all of this down in Python. Oh, I mentioned the geophysical sciences before. So Shel Genterman has stated that oceanographers produce massive simulated data sets on the petabyte scale of the Earth's ocean. And they couldn't even look at the outputs before Dask, okay? So she uses Dask to decrease the time spent on computation and programming and increase the time she has to analyze results. A lot of meteorology officers, such as the UK Met, use Dask, and most national weather services do as well, okay? So having said a lot about the uses of distributed compute, and in particular Dask, I'd just like to say a few words about Dask. So Dask essentially accelerates existing Python solutions. It was born of the PyData ecosystem. As I said, the CEO of Coiled, Matt Rockland, created it 5-6 years ago. Actually, yeah, six years ago. Dask had its birthday recently. And it came out of discussions at Continuum Analytics of how to scale data science in the existing PyData ecosystem. They wanted to answer questions such as, if we have someone who uses NumPy, but they have an out-of-memory data set, a larger than memory data set, what can we build to facilitate them doing the same analysis, but at scale? Similarly with Pandas and now scikit-learn as well. So I'm going to switch to a new slide now, but I want you to notice we've got, your import NumPy as MP or NumPy. I'm not going to get into the NumPy wars. Import Pandas as PD. And you've got x equals np.ones, x plus x transpose minus x mean. Similarly, PD read CSV, df group by for the data frame. So now, when we import a Dask array, it's as DA, and we have DA.ones. We have exactly the same code as we did previously. Similarly, with the data frame, DD.read CSV, whoa, instead of PDs. The group by is exactly the same. And similarly with the machine learning example. So essentially, your code, for the most part, will generalize, so it meets working PyData scientists where they are PyData scientists. And as I said before, one of the key aspects was making sure that it's as easy to use as possible. And so it does, for the most part, execute the NumPy and Pandas code in the back end. And you can see here that a Dask array essentially is a collection of NumPy arrays, as a Dask data frame is a collection of Pandas data frames, and so on. So just to recap what we've gone through here, we've talked about the wins of big data. That looks like big data wins. Like, okay, yeah, it's the winner. That isn't my intention. Then we talked about the big compute successes across a variety of verticals, and then a brief interlude to Dask. So now I really want to get into the nuts and bolts of scalable data science and machine learning, and how we like to think about it. So I want to talk about when you need it, and also when not to use it. I do work in marketing and evangelism, among other things, but I want us to be able to find users who actually need the products we build, and I want to dissuade people who will not need it. So I think that's incredibly important to discuss and to talk about, to that end, data size versus model size scalability concerns, okay? So this is Tom Augsburger at PyData in NYC 2019, and a fantastic figure that he produced, talking about when might you need scalable and distributed data science, okay? So we see we have on the x-axis here, data size. On the y-axis, we have model size, okay? And so it's a 2 by 2, okay? And we'll get to each of these squares in a second. When do you not need it? If your data fits in RAM and your execution of your code runs in enough time that you're kind of cool with it, okay? So we'll get to the case in which it's CPU bound and your model is too large to actually run. And oh yeah, I love that someone commented about ChiPy or ChiPy, and this was the first thing that came to mind, and I'm glad people are happy to laugh about it, because the NumPy wars are real. But yeah, that's funny. Okay. So if your data fits in RAM and your code executes quickly enough, then you're cool. Then I would not encourage you to do scalable data science at all. We'll actually see a case when your data doesn't fit in RAM, but data that a subset of it actually performs well enough. And then you also do not need distributed data science, okay? So when to do it, right? So if you can't even load the data set into NumPy or Pandas, then the data set is larger than your local memory, and that's RAM bound, okay? So then you want to think about distributed data science. As I just hinted at, we'll see a case in which you want to start building iterative models or your iterative process on smaller sizes to see if there's any lift. Sorry, I just see these great comments coming in. With ChiPy, I love that. Sorry, I just lost my train of thought, but it was definitively worth it. Okay, so we'll get to the case when you want to test out like your machine learning model on a smaller data set and then see how performance increases or doesn't with more data. Okay, so distributed data science when you have large amounts of data. Okay, cool. So when not to do it, exactly. This is the example. So here, this is building a machine learning model where you're interested in the cross-validation score, how that increases as these are learning curves, how that increases when you increase the amount of data you use. So, okay, you use 5,000 data points, you have an accuracy of 96.6, you increase to 12,000, you get up close to 97, then you get kind of up to, and you see this plateau here, okay? So let's say you have 100 million data points that you can use. Do you really want to do you want to use all of that data if your machine learning model's performance plateaus at 30,000 data points? The answer is definitively no. So definitely do plot your learning curves and see as a function of your business question or whatever scientific question you're trying to answer, whether you get lift, whether you get better and better performance as you increase the size of your data. If the answer is no, I would not do it, okay? Because you incur costs when doing something like distributed data science. The other example, which I foreshadowed, is when your model size gets large, okay? And this is CPU bound. So one example is large ensemble models. If you're training lots and lots of models, such as a random forest with lots of trees, you can distribute that across threads and cores, right? So you do want to do that because that's kind of what we call embarrassingly parallelizable, right? Similarly, large hyperparameter optimizations, okay? So this is the big model side, the big model use case, which I think, sorry, Hasib has a great joke. Insert big data puns about losing train of thought. Love it. So I just want to correct a misconception that distributed data science is all about big data, whereas actually it's about big models as well and complexity science. Great. And so, as I said, CPU-bound problems, the data can fit in memory, but it's just taking too long. I'm okay if it takes a minute or two to train my model, but if I have to wait overnight, that's really annoying and it breaks my flow with my work, okay? But first, of course, there are solutions before doing distributed data work. Choose a simpler model, maybe. More parallelization by buying a bigger machine. And if you have like a really massive machine, that's cool. Use it. A lot of people don't. And then you can do distributed computation with Dask. Okay. So just to recap what we just went through, talked about when you need scalable distributed data science, when not to use it, and data size versus model size scalability concerns. Now I want to talk about culture. As I said, actually, I think what I was about to do was just like say things that are on my next slide. So the first thing I want to talk about is a deeply cultural issue, which is data science leakage, and we'll see what that means. And I just want to talk about how we got to this state of affairs in data science, and then even think about, wait, like where are we? Do we know where we are? And talk about the establishment of healthy data cultures, which we're only starting to figure out. And then think about a case study in distributed compute. And currently I'm a core, and we're building tooling and data infrastructure stuff. So I'm going to focus on the tooling side, but there are several moving parts that we need for healthy data cultures. Okay. So a while back, late last year, I tweeted out how much of your organization's data work is actually used in decision making. And that decision making could be automated. Okay. And I gave a poll. And you'll see that over half the respondees said only 0 to 25% of their organization's data work is actually used, okay? Then another 26% said between 26 to 50%. So what I just want to make clear here is that 80% of respondees of 187 votes said that under 50% of their organization's data work is actually used, okay? And that's what I mean by data science leakage. Having worked in data science for a while now and spoken with a lot of data scientists, I got an increasing sense that a lot of people feel the work they do isn't actually used. What that means is either it isn't used or they just feel it isn't used, both of which are very serious problems. And I actually think it's the former. I think a lot of companies have invested a lot in data science, but haven't built cultures around the investment, which allows the fruits of the data work to be easily ingestible and fed into the decision-making or decision science process, okay? Now, to this end, a friend of mine, Mikhail Popov, who is a senior data scientist in product analytics at Wikimedia Foundation, Wikipedia, among other things, he responded, that feels like I don't know should be an option. I don't even know how much of the data work is actually used, okay, which is telling. Tanya Casciarelli wrote, and actually, yeah, Michael Thomas actually mentioned, I spoke with her on a podcast I used to do called Data Framed, and I love that conversation with Tanya so much, and it is about things along these lines, about how much data work is actually utilized. And Tanya actually responded that she'd argue that no one even measures the impact of data science and data analytics that well. So this is a wide open space, right? So this is kind of the state of affairs, and I just want to talk about how we got here. Of course, you know, lots of people are like, I was a data scientist before that was even a blah, blah, blah. I did the, you know, I worked in finance in the 90s and, you know, did a lot of bad things. No, I'm kidding. But of course, there are a lot of people who did all types of analytics and programmatic analytics that were doing data sciencey type stuff before we came up with this term. And then Tom Davenport and DJ Patel, as we probably all know now, in 2012, had an HBR article called Data Scientists, the Sexiest Job of the 21st Century. I think this is actually really important. This is actually a really important moment because what this article created was an avalanche of supply in the data science talent marketplace. We saw the evolution of boot camps. We saw online education sprawling. We saw data science then. We saw statistics departments at Ivy League colleges rebrand as data science places, right? So I think it's incredibly important to recognize that data science, there was demand for data science before this article, but what this actually created in the marketplace of data science work and data science need, on the supply side, it started to create around this economy of data science work, a lot of supply of data analytics, okay? And so we can then ask today, where do we stand in terms of where is data science in the hype cycle when this hype was created in 2012? We saw big data is in the trough of disillusionment. What we can see is that data science is still going up and up and up. And I do think that this will be very different across a variety of verticals, okay? Because I do think it has created a lot of value in tech. And, you know, my question around decision-making versus human decision-making and the data science impact on decision science versus automated decision-making, such as what ads to show, what search queries, what search results to show with respect to a query. In tech, in the automated sense, I think a lot of value has been demonstrated. Not anywhere near as much in the decision science. I'll also just flag that up to now, we actually have data science has caught up to big data in terms of the average number of queries over this time. Okay. So where have we seen the biggest wins? As I just stated, in tech, definitely. In automated decision-making, sure. Where else? I ask you where you've seen wins, but I don't think we've seen it in informing the decision function in the way that we'll need to, okay? So to this end, I actually want to show a slide from Renee Renee Teat, who you can follow on Twitter at Becoming Data Sci. She used to have a wonderful podcast called Becoming a Data Scientist. She provides a really nice framework for thinking about the role of data science and analytics in any organization. Essentially, you have a business question and you want a business answer. And a data analyst or a data scientist job or a team's job is to factor that process of business question to business answer through data question and data answer. So you want to translate the business question into a data question, then answer the data question with a data answer, then translate the data answer back into a business answer, right? And in terms of a decision maker who needs to make the actual decision, an important question is, what do they need to know about the internals of that? It doesn't necessarily need to be a black box, but you do need to abstract over a lot of, do they need to know about statistical significance? Probably not. What I do think they need to know about is risk quantification, risk management, and uncertainty quantification. And we could all become a lot better about communicating uncertainty, particularly when it comes to business. And of course, decision makers in businesses are really good at this. That's why their businesses are still around. Well, that and luck. Okay. To this end, McKinsey actually a couple of years ago came up, they proposed a new role, which is catching on in a lot of places, called analytics translator. This is someone who understands the business. Sorry, I just love this guy with I don't even think there's anything on that board that is pointing to. And he does look like the data version of Patrick Bateman or something along those lines. But the point is that this is someone and a role who, so I'm also wondering what she's thinking about, because it's definitely, she's like, this guy is definitely sub interesting. And this guy's all in, but enough analysis of the photo. The intention behind this role is to have someone who can speak the business language and the data language to sit in a translational role in the middle there, to translate between the business question, business answer, and data question and data answer. And I think this type of specialization is going to become increasingly important. A lot of the time it happens in management positions and leadership, such as, what is now your chief data scientist or chief data officer, these types of roles. But you're going to see them increasingly across departments as well, is my prediction. So I am very interested in thinking about how we build out these cultures, okay? And there are, I've identified 5 throughout a lot of conversations with different people, 5 key moving parts of data cultures. The first is an analytics vision that's aligned with company strategy. The second is strong C-level support. The third is value from early use cases. The fourth, data foundations, infrastructure tools. And the fifth is making it stick, which is cultural and redesigning processes around these. And each of these things could be its own talk. And well, I have given these talks. I can't, there's not one that I can actually pick out that's more, you need all of these, right? And yeah, I mean, the strong C-level support, it needs to be top down. Everyone is ready to buy into data, but you do need to demonstrate value early on. Otherwise people, there's a lot of money going to these things. And if you don't get value early on, people get, become skeptical very, very quickly. Okay, but I want to talk about the data foundations and infrastructure, tooling stuff. But before that, I just want to give a few resources. I had a conversation with an analytics manager and head of data science at Quantum Black from McKinsey. And this is, how old is this? This is 2.5 years old now. Look at that. My conversation with Taras. But it's still quite relevant with respect to everything I've been talking about now. Andrew Ng has a wonderful playbook called the Ai Transformation Playbook that I would also recommend reading for these types of things. One of the final things I did at Data Camp actually was we wrote a white paper or an ebook where we performed a survey with 250 odd companies about their levels of data literacy and data fluency. And you'll see that the ones with mature data fluency competencies had all of these far more on lock than those with immature data fluency competencies. And these are the things we've just talked about. Create a vision aligned with company strategy, C-level support, early value, process redesign, data infrastructure, okay? I also had a conversation on the podcast with Brian Granger, who you may know as co-lead of Project Jupiter with Fernando Perez. And something Brian said to me, it speaks to the cultural aspects a great deal, is that we are now entering an era where large, complex organizations need to scale interactive compute with data to the entire organization in a manner that's collaborative, secure, and human-centered. Another way Brian framed this is as a phase transition, because he's a physicist, as a phase transition from an era in which organizations have individuals who are using open source tooling to organizations themselves required, because of the power of open source tooling, to take it on at an institutional scale, okay? And one of the reasons I joined Coiled and joined Matt in building products based around open source is because I firmly believe that the open source is wonderful at meeting individual scientists and researchers and data scientists and analysts where they are, but not necessarily organizations. So the way I think about it is, for those who are network theoretically inclined, an organization can view as nodes of people with edges, which are relationships. And OSS solves for the nodes really well, but not necessarily the edges in the graph, okay? And so what was the promise of big data and big compute? The promise was big data plus data science teams equals up and to the right, exponential growth. And there's actually a lot more to it if you want to do it safely and well, which you do, right? So to that end, Matt and I have written a series of articles around the fact that all of these things, working with big data and big compute, comes with a big headache. And we framed it as the unbearable challenges of data science at scale. And so I want to run through a few of those pain points that we're trying to solve for, okay? So when data scientists burst to the cloud, they need to know, do all their machines have the same software installed? Can they upgrade packages easily? Do they have the same packages on the cloud and locally? The resource sharing, can they share the same machine with their teams? How quickly can you get 100 machines, even if only for a few minutes? Data access, where is your data? Can your machines access it too? The big headache is for team leads and management as well. Cost avoidance, cost tracking, optimization, enabling collaboration. So this is something we're working on, is advanced telemetry for team leads. I really should have said that's kind of the reason for the genesis of Coiled, is building a product which allows data scientists to burst to the cloud. So we call it one-click hosted deployments, where they can burst to the cloud without doing any of the AWS, Dockerization, Kubernetes stuff, and get their cluster up in the cloud and make sure it's synced with their local environment and access it from their local Jupyter notebook or IPython or PyCharm or wherever they happen to work, and not need to use, for example, a Databricks notebook. IT is a really important stakeholder in the culture of distributed compute. Can they, what type of predictability can they be ensured? Can they ensure that critical production workloads will continue unimpeded? Security, is sensitive data protected? And observability, can we see what's happening? Can we have that type of insight? So these are the types of pain points we're solving for at Coiled. And if you want to do distributed compute or spin up a free DAS cluster, definitely go to cloud.coiled.io. Our birthday's next month as well, and we're actually opening up free, our first birthday, free GPU access to all new customers and all new users then. And just to clarify, when you go there, you can spin up clusters on us, and there's no credit card required for up to 100 cores currently. To recap what we just did, talk through data science leakage, how we got here and think about where we are, talked a bit about healthy data cultures, and then looked at a case study in distributed compute and in particular tooling. As I said, take our free cloud product for a test drive, cloud.coiled.io. We're hiring a lot at the moment. So please do check out our jobs if it interests you. Follow us on Twitter, check out our live streams. And for the slides, you can just drop your email there and I'll send them to you. That's it, everyone. Thanks in all Pythonic glory. I really appreciate all of your attention. And thanks once again to Joe and the organizers for having me here. It was so much fun.
Well, thank you very much for the talk. I really, it was interesting. Made me think about data science in a little different way. I guess we can open up the chat for questions. But in the meantime, I have a few of my own, I guess. And one is, you mentioned about like kind of the hype, where we are on the hype curve in the data science world, and that there's like a supply and demand. Do you think that right now kind of the supply and demand are matched in terms of people hiring and data scientists looking, or do you think it's kind of skewed or in one way or the other?
Yeah, that's a great question. I think it's both very highly unmatched and matched in a way that, so let me talk about the unmatched. The supply side of people wanting to be data scientists is far more than the actual demand. Having said that, I do think people who think they want to be data scientists maybe want to be data professionals in other senses, and there is going to be increasing demand from that. Data engineering is probably the best example. So when anyone comes to me and says, I want to be a data scientist, how do I do that? I kind of interrogate them as to their reasonings behind wanting to be a data scientist. A lot of the time it's like, actually, you could be a data engineer. So I think if we view it in that lens, there is increasing demand for data engineers and increasing demand for data professionals. Another example is a lot of people think data science needs to be machine learning and this type of stuff, whereas data analytics is such a huge space. So the increasing specialization, what we're seeing, you even see job postings now for data analyst, visualization specialist in R, these types of things. So I think on the podcast I used to run, Hillary Mason once said to me, will data scientists go the way of the webmaster? And what she meant by that is, we've ended up with front-end engineers, back-end engineers, all of these types of things. And I think we're seeing a fracturing of the data science professional landscape in which there is a huge amount of demand, but the supply needs to match that across the space, if that makes sense.
Sure. We have one question from Hasib. Says, what are your thoughts on data science versus data engineers?
So great question, Hasib. And that's a great beard as well. If it's anywhere near representative of your actual beard, I'm even happier. That's a good question. I'm trying to interpret it. I think the world needs more data engineers and less data scientists, and that's why I try to get data scientists or aspiring data scientists to perhaps pivot to data engineering. There is a classic tale in a lot of startups where a startup will hire their first data scientist and want all this analytics done, and the data scientist will start and they'll spend the first 12 to 18 months being the first data engineer because that hasn't been set up properly. So I will argue that data science doesn't work without data engineering and that foundational data infrastructure.
So I have a question. You mentioned that, like, you gave the example of like the polling where you have 1,000 people representing millions of people, and then also talking about how you could have the curves where if you add more and more data, you don't necessarily get a better result. And then further, that's some people or some companies are collecting data and only using an X percent of that data, a small percentage of what they collect. Is there such thing as like collecting too much data, or are we collecting too much data in general, or is there a point where we just need to collect data differently, I guess?
I think we definitively need to collect data differently. I think I'm probably a Bayesian in the sense that I think if we think about the data generating process, we can actually like think about how the data arose in the world, and model that as opposed to model just the data itself and try to extract as much as possible. So think in a principled manner about it. You can get very far with small amounts of data. I want to be very clear about something. I think we've entered a hallucinatory reality where we view like more data and more like abundance and more fruits of like web-based and app-based creepware in tech to be the solution for society's problem. It's coupled with like a weird tech salvationism as well, that tech can save us. And even, you know, you hear this conversation where people in tech are like, how do we use tech to solve the problems? How do we collect more data to solve the problems that tech has caused? And I'm like, what are you even talking about, man? So I do think we've entered a very dangerous space. And this is a philosophical question as well as a practical one, where we have an assumption or an axiom that more data means better. And this is also a legislative question. So I think with the advent of GDPR in Europe, CCPA in California, actually bringing down this idea of collecting as much as possible and thinking in a more principled manner around what you actually want to collect and why will become increasingly important. I didn't mean to get too political then, but I think it's an important conversation to have.
Certainly, yeah. I guess one last question. I don't see any more on the board, but one last question I have is, and I think you kind of alluded to this. Like, let's say you're getting into data science, and you have a like a large data set that won't fit into RAM. What would be your steps to get forward, like to get started? You know, learning Dask, and I think you know, Coiled sounds like a good option for that.
Yeah,
but
yeah.
How would you take it from there? I guess when
I would actually, so with my Coiled hat on, I would spin up a Coiled cluster. We offer free clusters up to 100 cores where we have quick start guides that will tell you how to import your own data set and this type of stuff to get up and running. That's immediately scaling out to the cloud, which I think previously wouldn't have been a good solution because you would have had to set up all the Kubernetes, Dockerized stuff yourself on AWS. If you didn't want to do that, you could do it locally. And so one mental model for thinking about it, when you get to medium-sized data, you can scale up locally and do out-of-core computing using Dask on your local workstation. And then if you get larger data sets, then you scale out to the cloud using something like Coiled Cloud or AWS. But I personally think if you work with Pandas or Scikit-learn or NumPy, Dask is what I'd start with. And particularly because, as I tried to make clear, it really meets PyData folk where they already are and arose from that community.
Great. Do you, before we end up your talk, do you have any calls for the community or the Python community in general? Calls to action?
Yeah, give me a second. Yeah. Writing code is really fun. And I think sometimes it's so much fun that it can be divorced from end users. So I'd encourage people to think mindfully, and I'm sure a lot of you do, but I need to remind myself to think more mindfully about the impact of my code and organizations I work in, and what the end goal of the code I write is. Because we all work for businesses, well, a lot of us do, that, you know, that have impact on society. So I think thinking in a more principled fashion about what we all do, and as people who write code, we do have a certain amount of leverage as well. And with great power comes great responsibility, right? That's a half joke, but yeah, I'd encourage us all to think more mindfully and as a community and have that conversation more broadly as well.
Well, thank you very much for your talk and for you know, all the good advice.
Yeah, thank you so much for having me, Joe.
Sure. So with this, I think we will enter into a 5-minute break, but stay tuned and we will be back with another talk. So see you then. All right. Well, welcome back from the break. We will get started with our next speaker right now. So I'm going to bring Kevin onto the stream. Welcome to ChiPy, Kevin. Thanks for joining us. And for those out on the stream, Kevin's one of the core members or core contributor to ChiPy and runs a lot of our projects. But why don't you describe yourself a little bit to us? How did you get involved with Python?
Yeah, so I basically I started my career with Perl, and we were rewriting our code in my first job to Python, and I'd been there for a while, and I wanted to join a programming group, and I like Python, so I started doing more and more Python, and I joined the Chicago Python group. So
cool. Now, I think I know the answer to this question because it's the title of your talk, perhaps. But just wondering what your next favorite language is compared to Python, and why you chose it, or maybe your talk will get into that.
Yeah. So yeah, I mean, Perl. No, I'm just kidding. Rust, yeah, is my talk, and I'm going to that is something I've been getting into, and I do like it. So
great, and I look forward to hearing more about it in just a minute. So we've all been dealing with a lot over for COVID and such for the last year or so. How have you been managing during this time?
Yeah, in the beginning, I definitely enjoyed it to have a break from everything. But after a few months, I wanted to get back into normal. So like everybody, it is a struggle. And I have definitely been using the time to do more coding and play video games, unfortunately.
I do the same for sure. All right, great. I'm looking forward to your talk. Let's get started. If you have a screen you want to share, I could add that to.
All right.
To the stream.
Let me figure that out. All right, that's the screen.
Let's see. I don't see it yet, but there it is.
Can you see it now? Okay.
Yep. All right, take it away.
All right, so the talk is going to be on Rust, and it's going to be on Advent of Code. So I did Advent of Code in Python last year in 2019, and this year I did it in Rust, and I was going to talk about Rust and also Advent of Code and compare and contrast. I also did a talk on Rust before too, and I'm getting a little rusty, so that's why joke there, but wanted to do Advent of Code again. So getting started here, I think that using Advent of Code, as we heard from Stephen in the first talk, is a great way to connect with the community, and I would say it's also a great way to learn a new programming language, but it is pretty difficult in general, even without learning a new language. So you are adding more things. Simple things are going to take longer, and no pain, no gain, they say. So maybe if it's your first time doing Advent of Code, maybe not, but otherwise you could learn a new language. So what is Rust? And Rust is a language developed by Mozilla. It's pretty new, and it's been getting the most loved category in the Stack Overflow surveys, whatever that means. But so what is a low-level language? So it's basically closer to the hardware. There's less abstraction. I would put Rust between Java and C++ in terms of how much control over the hardware versus how many higher-level language features. So why use a low-level language? Well, it's faster. There's you have more control over memory, and it's also a learning experience because you get to learn about the internals of how things work a little bit more. It also is slower to develop in, and it's going to require a learning curve and more syntax and more code. So maybe, instead you might want to use Python, but a lower level tool like NumPy, or that's a third option as well. So this is just jumping right into it. It's a hello world in Rust, and it's just simple printing some numbers. And something to notice here is that the data types are explicitly defined in 32, and also the print is kind of similar to Python with the curly bracket syntax. So now I'm going to shift gears into advent of code. And so what I did here was I was comparing my times, personal stats in Rust and Python. So on average, according to the advent of code sites, it does measure the time when you start doing the problem. And on average, I was about an hour slower on Rust, an extra hour of time. And also about 25% more lines of code. So 45 lines of code average, 60 lines of code average with Rust versus Python. Now, this is not a great measurement because this was actually Python in 2019 and then Rust in 2020. So the questions are different. And I took the first 8 days because it seemed like I had more consistent data there. But, take it or leave it. That's kind of like how it went for me. Of course, I did get better because after 2019, I was more familiar with advent of code. But then Rust, there is more of a learning curve. So this is a performance comparison. A little bit different here in how the code is running. So I chose day 11 because this one actually took a long time to run. It involved going through a grid and looking at all the adjacent squares in the grid and then timing it, and then making a calculation. So what I did was I timed it in Rust and in Python using the code as exact as I could get. And what I found out was in Rust, it ran in about 2 seconds in debug mode, and then in Python, it ran in 1 second. So in Rust, like the default mode is the debug mode, but there's also a optimized version that you can have a flag, similar to C++. So after running the optimized version, it was actually a lot faster, 0.1 seconds. And then with Python, there isn't really an optimized mode, so it's not really the best comparison. But using ChiPy instead of regular Python, there's more optimizations with the looping. So that actually made it go to 0.3 seconds versus 0.1 seconds. And I was kind of curious about this, so I decided to do the same thing with day 15. And day 15 was a little bit of a different one, and that was basically a giant loop of 30 million elements, looping through, calculating 30 million times. And so it was a very simple code. And in the Rust debug mode, it's actually faster this time with 4 seconds. And then in the Python, it was slower with 6 seconds. But then if you look at the optimized code, it was actually faster in Python, in ChiPy, than in Rust. And I was trying to figure out why. One thing I came up with was that if I changed the Rust data types from int64, which is the default, to int32 was about the same. I'm not exactly sure why that is, but it might have to do with the default, which was 64-bit integer versus 32-bit. So with these stats out of the way here, I wanted to basically just go over some of the Rust syntax, just jump into Rust, and then jump into more adventure code. So in Rust, basically everything is immutable. So by default. So in order to change something, you need to specify that it needs to change. And unlike Python, you everything is mutable except for certain types like integer and string, which are immutable. And I think like Guido said, we're all adults here, indicating that Python there's just a lot more flexibility, and in Rust you do have to explicitly define everything. So it's a lot about safety over easy to work with. So with that said, that brings us to the mute keyword in Rust. And basically, in order to assign a different value to a variable, you always need to use the mute keyword. And here we have x equals 5, and then we have x equals 6. So, and then the error is cannot assign twice to a mutable variable x, and that's because we did not use the mute keyword, so it's a constant. We need to use the mute keyword in order to basically change a value. So that brings us to the next thing, which is going to be how objects are passed by reference in both languages. And this is something that can be a little confusing, that is different in Rust. And so in Python, starting with Python, the way that the objects are passed is that, for example, you have a list of numbers, and you can have multiple references. So let's say you have a list in X. Now you say, okay, Y equals X. So now you have a reference in Y to that same list. And it is, you can modify it in Y, you can modify it in X. It's all the same variable, and it's pointing to the same list. And this is because it's a list. And if it was a string, or if it was a different kind of variable, then, or I guess maybe a better example is an integer. You would actually, it would be copied in Python. So here, really, in terms of an owner, you can't really say that X or Y is an owner, but in Rust, there's the concept of ownership. So in Rust, if you were to do the same thing, if you were to have a vector assigned to X and then say Y equals that vector, what happens is you're actually moving it into Y. And if you wanted to do a reference, you have to use the ampersand. So only one variable is the owner. In this case, in this example, it's Y. So for example, what you can do is you can have a list, and then you would pass it to a function, write to file, for example. Now, if you were to do this, what would happen is that in Rust, the owner would actually shift inside the function. So it would start at X in the variable, but then it would go inside the function write to file, and it would be moved in there. So if you try to print it after you moved it, then you would have a compile error because of the scope. When you pass it into a function, it's the function scope now. So it will actually change scope, and that's why you have the compile error. So this is just something that that it would trip you up if you not familiar with how the passing values works in Rust. So you would always have to, if you would like to use the value later, you have to pass it by reference. And this way, the function actually borrows X, and you can actually use it later by printing. Getting that out of the way, I wanted to go over some syntax. In Python, you have a list, you're appending to it, and then you're looping over it. In Rust, you would basically make sure to use the mute keyword because you're modifying it, you're adding a variable, and then you would loop through it, and you would use the reference keyword there because when you loop through it, it's calling a function, and you need to specify whether it's a reference or not. And it is pretty confusing sometimes, especially with advent of code, when you are trying to figure out, you pass it into a function, so it's a reference. Okay, so now it's a reference, but before that, it was not a reference. So it's something to keep in mind there. List comprehensions, you can do list comprehension in Python. In Rust, there's a lot of functional programming paradigms that are used. And for example, filter and lambda functions, which are also used in Python. So you could do something similar in Python with a lambda function. And of course, everything is explicit again. So that's just some of the syntax there. Some of the syntax on functions is you have to basically, the difference is you have to specify the return type, and you have to specify the input type in 32 there, and then a Boolean. It is tricky because you can't mix types, and in advent of code, you've got a lot of different things going on, and well, I guess with programming in general. So it's something to keep in mind when you have to mix types. So dictionaries are used a lot in Python. And in Rust, they are hash maps, and the difference here is basically the syntax is a little bit different, and you have to specify, you have a string as the key and then an integer as the value, as I have in this example. In Python, you use dictionaries a lot for keeping track of data. So you have like maybe person equals a dictionary, and maybe that's name and ID. In Rust, basically, a lot of times you would use a struct instead, which is a little bit similar to a class. And it's basically the convention here to use that instead of a hash map. But in Python, typically, a dictionary is used instead of a hash map. That's basically just some syntax and convention things. With some of the things out of the way, basic syntax and some of the things that can trip you up in Rust, I wanted to basically go over some of the advent of code questions. So in day 4, for example, is something that what you needed to do in advent of code is you needed to basically pass in a point, and you need to basically see, okay, is this a tree or is it not? And you would return true or false and then do some more processing. But then if it's out of bounds, you would need to do something different. So there's basically 3 states: true, false, and whether it's out of bounds. So in Python, what you might want to do is you would maybe throw an exception. So in Rust, you can't interrupt the execution of the program with an exception. So it is a little bit tricky in that way. And then also you can't mix types, or you can, but it has to be defined before. So what happens is you have this result type, and the way you do exception handling and errors is you basically have a different type, and it's okay or error. And you would check the type. You'd say, okay, if it's okay, then let's look inside, and if it's true or false. If it's an error, then let's look inside and, well, I mean, get the error message, I guess, or do something else if you need to do something else. So that was day 4. And also in the first few days, parsing was definitely a challenge. And parsing was a challenge because, you know, there's different string types in Rust. So there's you know, there's characters, there's strings that can be mutable. There's immutable string types that are references, Unicode, bytes. So you kind of have to keep track of different kinds of data types. And if you want to, for example, convert a string to an integer, the syntax is a little bit more heavy, and you would use the parse function, and you would specify what to convert it into. So here you do that parse usize, which is an integer. So you'd convert the string into an integer, and then you'd call unwrap. And the unwrap is basically part of the error handling. And it basically means that if there's an error, then crash the program. You know, you only use unwrap if you're confident it's not going to crash. Otherwise, you would just have an if and else statement. You know, if it doesn't pass, then you would do something else. So that was day 1 through 4. Day 7, basically, there was a problem involving recursion. And what you had to do is go through a tree and count up the different colors in this tree. And in Python, what you might want to do is you would have a dictionary, and then another dictionary, and then an integer to count, to represent a tree, basically. But in Rust, if you wanted to do it the Python way, you would get a lot of explicitly defined types. So here, you know, you have like hash map string, and that's basically kind of just a nested structure of a dictionary in Python. So you know, by day 7, I was like, okay, well, you know, this is getting a little bit, you know, should I quit? You know, should I keep going? And so it was kind of, you know, I decided to keep going. And when I got to day 9, I did actually find that something that in Rust that I actually had an easier time than doing in Python, which was this function called windows in the standard library in Rust, which allows you to go through a list, and instead of going through each element, you can call .windows, and you can get a window of that list, of that array. So you can do like the first 3. If you pass in 3, for example, into the windows, you would get the first 3 elements, and then you would move over. Okay, then the next 3, and then the next 3 overlapping windows, and you can pass in that. So for day 9, it was pretty nice to use this because it just happened to work out for the problem, and where you had to slice the window through it. And then when you wanted to, for example, take the min or the max of a vector, what you would do is you would iterate through it using an iterator in Rust, .iter, and then you would call .min on that. And also there's the unwrap in case it's empty, which will throw an error. So the unwrap will basically ignore the error, and then if there is an error, then it will crash. So that was day 9. And then another problem I ran into in day 11 was with the signed versus unsigned integers. So in Python, you only have one type of integer, but in Rust, you have a few different types, and the most basic types are positive integers, negative integers. So unsigned is going to be a positive integer, and then signed is going to be integers that can be positive or negative. So what you might want to think you do is just always have a signed integer, in case you need to go negative. But the issue is that in Rust, when you're indexing into an array, you have to use an unsigned integer. So you have to use an integer that can only be positive if you're indexing into an array. So because of that, if you need to look at a coordinate system, for example, and you need to look inside a coordinate an array, and then your coordinate system can go negative in a grid, for example, and you need to see, okay, is this negative? If it is, I want to do something else. So in Rust, basically, you have to do a conversion. So you have to say, okay, well, I need to subtract from this number, but I can't subtract from a positive number because this number can only be positive. So if I subtract -5 and it's 0, then it's -5. Well, I can't have a -5. So what you have to do is you have to convert it into a sign number that can go positive or negative, and then you can, and then when you're done using your calculations, then you convert it back into a unsigned number. And the reason why you have to have it unsigned is because when you have an array, a list, you have to, Rust makes you use the positive numbers only, so you can't use the other data type. So that was another thing I ran into. By day 18, this one was the one that I had the hardest time with, and this was like a problem where you had to basically parse a lot of symbols, math symbols, and then you had to use recursion and try to figure out, for example, where the parentheses are and what the calculation is. And by this point, it's getting to a lot of code, a lot of parsing, and it's getting complicated. And after this took me maybe a few hours, 4 or 5 hours. I was like, I think it's time that I call it a month, and with the advent of code. So overall, I'd say it was definitely pretty difficult, and I did get a lot out of it, though. Learned a lot about Rust and how things are. I did almost quit a few times during the day 7 and some of the day 6 and things like that. So I was close to quitting, but I did actually go through pretty far, and it did work out, and it was also good to have the community to go on the Slack and see what other people are doing. Oh, this person is doing it this way in Python. Maybe I should see how I'm doing it, and maybe try to change it, or maybe do it in a more efficient way. So there's different things, and overall, it worked out. So yeah, if you're interested in learning about Rust, there's a lot of tutorials on YouTube. There's a Discord, Rust community Discord. The official book is pretty good, which is basically the official documentation that they made into kind of like a book kind of thing. They call it the book. And there's also a Rust meetup as well, which has not, in the last few months, it's been under hiatus, but I think it's starting back up in the new year. So that's some additional resources if you're interested in learning Rust. So yeah, with that said, that's pretty much the end. So yep.
Yeah, thank you very much. That was an excellent talk, and it was Rust has always been one of those languages I've kind of wanted to pick up because it looks really interesting. I'm one of those people in the survey that says it's like the most wanted to learn. What's your impression? Kind of. So you mentioned there's kind of an overhead, or like in doing comparing Python and Rust when you were doing the advent of code. You found yourself taking a little longer to do Rust. Is that because the language is a little bit more complicated, or is it just you're getting up to speed with Rust, or what, what's your impression of that, I guess?
Yeah, I mean, I think it's a mixture of different things. It is more complicated because there's more syntax since you're dealing with things that you're not dealing with in Python, for example, memory management or, specific data types. So there's more things, there's more syntax, and also, I'm more comfortable with Python. But then again, since I compared 2019 to 2020, maybe I was also better at advent of code in general because I had done it before, although there were different questions. But I had a more understanding of how advent of code is. So
cool. We have a question from Ray Berg. Any projects you're thinking of picking up for long-lived Rust work?
Any projects I'm thinking of picking up right now? I think for right now, I think I did a lot of Rust, so I might do something in Python to see how I've had enough Rust, but definitely I am a lot more comfortable with it. So.
And another question from Ray: what's the number one thing you wish Python would import, pun intended, from Rust-lang?
Number one thing that Python would import from Rust-lang, well, I did like using that Windows function to split up into a list into different pieces. But I mean, that's not really something that's like super widely used. That
was pretty neat. Yeah.
So
I have a quick question. What is your impression of the kind of the package management system, or how, as compared to Python, how do you like Rust's package repository and their means of installing stuff?
Yeah, so the package repository is pretty nice. It is similar to Python in that you have a requirements file and you list out the requirements, and that is actually required for every project. So when you use the tool Cargo, which is how you run your Rust code, the recommended way of running your Rust code, you specify a requirements file, and you need to have that for every time that you have dependencies, or even if you don't have a dependency, you still need to have a file like that, and the tool will actually make one for you when you start a new Rust project.
That's pretty nice. I guess before we end, do you have any calls to action or announcements or anything for the community?
I'd say to just keep learning. There's more time right now to learn new things, and because keep learning and check out the Algo Sig, which is an event that I'm a co-organizer for, and then I guess Project Night sounds pretty good too, because it sounds like it's coming back next week or two. So
I'm looking forward to all that stuff. Yeah. Well, thank you again for your talk, and happy rusting, and hope to see you at the Chippy Town or at the next Chippy meeting.
All right. Thank you.
Bye.
Bye.
All right. Well, that's Chippy for tonight. Thank you all for attending. I'd like to give a special thanks to Stephen, Hugo, and Kevin for being excellent speakers for this month. Also, thank you to Ray Berg for helping manage the stream, and to Ali Sivji for arranging all of the great speakers we've had today. And one more thank you to, of course, Jfrog for sponsoring us. And I will put up the raffle information up here again. You can find that also in the chat sidebar. So sign up here for a chance to win some prizes. But we're not done with Chippy. We are going to continue. If you love Chippy and want to continue to hang out, we have a space at https://chippy.town, and I will share the link to that right here. Chippy.town. Come here and hang out for the after party. It's a lot of fun and gives us a chance to kind of talk with people who are part of the community. So if you enjoyed the talks and want to continue to subscribe to our YouTube channel for more and upcoming talks in the future, we have a bunch of stuff planned, and we look forward to seeing you there. So thanks again, and until next time.